Hey everybody. So here is a reminder of the little quiz that we took just in case you weren't there that day. I have the data from all 10 of our questions, and then this also is one of the worksheets that you were given. And so the whole group analysis we'll start with, those will be our one sample procedures. So first a confidence interval, just picked 95% just because. And then the book section is 10.1. For number 2, suppose the true mean score, that'll be the test we do in a couple of days. And we're going to fudge this a bit because our scores were a little low. So just to work through, we'll make it a 5.8. To see if there is evidence that AP Stats students are more intelligent. We will then look into the 2 groups, and I have these numbers already calculated as well. Excuse me. For number 3, we'll do the confidence interval for the true difference in the mean number correct, which is section 10.2, and then to see if there is a difference between the 2, if one is smarter than the other. So these are the results from each of the 3 class periods, just the number out of 10. And so I have put into mine, my summaries are listed at the bottom. All of the males, all 29 of them from all 3 classes that were present that day, are in list 1. All of my females are in list 2. And then I made a combined list of all 54 scores into list 3. So pause the video, take a minute to put all of that in your calculator, and then go to stat calculate and run the one variable stats just to be sure that your means and standard deviations match mine, to make sure there aren't any errors entering all of that in. So, and just as a reminder, these are the 3 that we're going to do. So first the confidence interval, and then a 1 sample test, and then we'll move on to the 2 sample procedures for the difference between them. So for our 1 sample 95% T confidence interval to estimate mu. Again, in the state plan, we need to name the procedure and then work through conditions. And so our 3 conditions are random, not exactly met, as this was more of a convenience sample. That's okay. Independence. We have, 54 total. So sampling without replacement. Our 10% condition is met as the population of our school is well over 10 times 54, or 540 students. Normal / our large counts condition. This one now again is a change from what we were used to in the past. The central limit theorem applies. As our sample size is more than 30. So no matter the shape of the population distribution, our sampling distribution of the sample means will be approximately normal. So this again, different from what we've done before, and we will get into when we look at the 2 sample procedures, and we're looking at just females and just males, because each of those counts individually are over 30 or under 30, excuse me. We have to check them separately. And so we'll look at the calculator on those to see whether or not we have outliers and if we have an approximate bell shape or not. So for the do step, I have the formula just listed there, but I'm going to switch over to handwrite some of these values instead. Okay, so as you saw, we have x bar plus or minus t star, which is our critical value, times s divided by the square root of n. So x bar is still the estimate. Everything after the plus or minus sign is still our margin of error. None of that is new. Our x bar was 6.185 plus or minus. It's the t star that we don't know. So I'm going to leave a little gap right there. And then s is 1.3 34689 divided by the square root of n, and we had a sample size of 54 when we put everyone together. So T star is based on degrees of freedom. So our degrees of freedom, and the abbreviation is usually just DF, except that's a very messy one. So degrees of freedom, DF, would simply be 54 minus 1. This is like me having my whiteout in class. So 54 minus 1, we have 53 degrees of freedom. So the trouble is, when we go to take a look at the table, there isn't going to be a 53. Okay, so here we are again looking at table B in the formula packet. If we look at the degrees of freedom off to the side, we don't have a 53. So when I had said round down to the nearest one, we have to just drop back a little bit to 50. If you go over to the row, and this one's from the bottom up, so looking at the 95% and where that intersects, our critical value would be 2.009. Okay, so from the table again, we couldn't use the 53, the row doesn't exist, but we have 2.009 from row 50 instead. So we have a mean of 6.185 plus or minus. If we key that into the calculator, I get a margin of error of 0.3682. And so my confidence interval is 5.8168 to 6.5532 for 95%. Okay, so switching gears, we had the work by hand and created that confidence interval on the calculator. I have my data already entered. So again, if you go to Stat Edit to see the 3 lists, I did males, females, and combined. So we're working with list 3 under Stat Test, our favorite place. The t-test we'll use, that's the 1 sample t-test we'll get to. 3 we never use. 4, the 2 sample t-test we'll do when we compare males versus females. Otherwise, we are looking at intervals. So the t interval will be the 1 sample t interval, and buried down a little bit farther, we'll see the 2 sample t interval. So you have 2 options. You can either enter the data if you have it, or if you only have the statistics, which is the way a lot of the textbook problems work, all of the stats being entered instead, not to so many decimal points, but mine's because I already have the data in there. But you could just enter all the relevant pieces. You just need the X bar. The calculator generates the T star. So then you need the standard deviation, the S sub X, and the sample size, and then the confidence level. So if we go to data entry, instead, I again have everything in list 3. This is raw data. So the frequency, everything only occurs one time. We can leave that as is, and then 95% if I calculate. My love-hate relationship with the calculator is that this, very, very similar to the results that we found, it does not give us the margin of error. And so to do that little bit of the calculation and just confirm that it is in fact working, I think is important, so that you can see where that center still is there at 6.185, and then just to get to either end of the interval is all. But otherwise, slightly more accurate because, again, it's using a better degrees of freedom. It's able to actually use the 53, so the T star is a little bit closer to the truth than what we did. Okay, so here we are back on the work page now. I took pictures of what I hand wrote and what was in the calculator, just so you can see again, they're similar enough. If we would round to the hundredths place, you end up with the same values. Hopefully it feels like it was very much the same as what we've done before in terms of the amount of work that was involved and what the formulas look like. And again, things are on your formula packet. And then the conclusion, same basic format. So we are 95% confident. The true mean, quote, IQ score for AP statistics students is captured in the interval from 5.81 8176. I'm going to use what the calculator gave me, and 6.5528. Just again, because it is a little bit more accurate with those degrees of freedom. So things that we will always need on this test as I scroll back up to the beginning. So under state plan, having it identified by procedure. So the 95% confidence interval, again, to estimate mu, that's the purpose of the confidence interval. On the AP test, you get credit for identifying it by name or the way the formula is written in the do step. Hopefully this is not intimidating at all, this formula, but they can get a little crazy when we get to 2 sample, and so by name tends to be a little bit easier. Conditions should be met. Random, of course, not so much. Independent, we were sampling without replacement, so we're just working it out a little bit. The normal large counts again, using the ever powerful central limit theorem to work through it. In terms of work, what you need to show. So the formula is there. Degrees of freedom have to be stated somewhere in the do step. So that is definitely a new part, working with the t distribution in these procedures for means. And then again, this is the same amount of work that we would have shown for our confidence intervals before. If instead of finding the 2.009, you just left that as t star and plugged in the other 3 relevant values, you can then state that the interval came from the calculator. I would check to see that it's reasonable, that it's something close with the inputs that you put in. But again, if your X bar and S are shown on the screen there just to verify what you had for the data when you entered it, then you should be in pretty good shape. And then our conclusion is the same as what it was before. We're just saying we're 95% confident the true mean is captured in that interval instead of true. And this, again, we can go back and forth since we're just making up and using our own data anyways. But if we're really looking at AP statistics students or all Mount Lebanon students, whatever it may be. So hopefully this makes a lot of sense. That is from 10.1, estimating a population mean. So you can read the section in the book and take a look at the 10.1 sapling.